Kick off. My name is Steve Mackay, um, and just really want to spend 25 minutes of your time. Thanks for joining us on this little, hopefully not heavy sales presentation, but focusing on how to enhance your career with a diploma, bachelor, or master degree in engineering. So we really just want to go through some of the key issues and then obviously follow up with questions and answers at the end so you can participate. So it's me, Steve Mackay, and I've been practicing engineering for 40 years now, so I'm quite an old lad, as it were. Perhaps worked in quite a few different areas of industry, oil and gas and mining and power stations, and it's been a very enjoyable experience, and still involved with projects as time goes on. So really just welcome to the presentation. As Carol says, there's a possibility that you will drop out because of your internet connection or your wireless connection, but don't worry, we'll give you the recording, and of course you could pop back in if you do drop out for whatever reason. So internet's fairly forgiving on that thing. So really the topics I really want to talk about are, first of all, engineering into technology. What do we do? Benefits for you. Again, hopefully I don't sound like a used car salesman. I was looking at the least trusted people, and of course, inevitably on the list, Shina, I don't know if you saw that, car salesmen are down the bottom, just below politicians, actually. And engineering professionals actually are second as the most trusted people. The top one, can anyone tell me who the top most trusted person is, Carol? Who's the most trusted professional in the world today?
I would think it might be someone like doctors.
Very close, but actually doctors per se are below engineers, quite a lot below. But and nurses are actually the most trusted. So there you go. Anyway, so the benefits are, we just really want to try and give you unbiased advice, trustworthy advice, and we engineers, so hopefully you can trust our ethical and moral ability. I really want to then just talk about the engineering diplomas. Thank you very much, Maro Mo. Doctors are certified killers. Okay, let's be a little bit careful here. We don't want to get this session out of control. But anyway, that's very good. Anyway, so we're going to talk about diplomas, bachelors, and master degrees. And I really want to just do it in the context of how they all fit together in the program structure, and then talk about articulation, range, and some other qualifications. Talk about what the difference between a 3 or 4 year program is as far as engineering degree, and then talk about master degrees. Talk about how we can get around you doing it online rather than in a classroom with remote and virtual labs. Just want to spend a few minutes talking about that. And then talk about one of the most important issues, which is accreditation. There's a lot of fly-by-night operators out there, and there's some very reputable universities who may not give you the qualification you want because they may not have the right accreditation. And then finally, we'll have questions and answers. And I'm going to try and do this all in about 20 to 25 minutes. Shine sometimes has her doubts, but that's where we are. So hopefully you can all hear me. If you can just text in the box if you can hear me. Please text in the box if you can hear me, just to make sure there's no surprises. Thank you very much. So really, we've been around for 25 years and run courses all over the world, ranging initially from data communications. As the internet started coming out, we were running courses on that. And of course, field bus, and then automation, electrical, mechanical, etc. And in the last 7-8 years, we've been running diploma courses and master degrees. And now in the last 6 months, we've been approved to offer bachelor degrees in engineering. And I'll talk about how they're structured and how they fit together. Instructors all over the world, and we pick people that are highly experienced. So for example, with this afternoon, we had a meeting looking at the results, and we had 4 instructors. One was in Spain, one was in Australia, one was in the UK, and one was in South Africa. Yeah, so they're all over the place, and we draw highly experienced guys that have been working in industry and perhaps don't have the ability to write a fast Fourier transform, but certainly they have the ability to run an engineering business and do engineering design. And the students are from all over the world. Shane, who's tuned in here, she counted 120 countries. So there you go. The important thing is, don't let career opportunities leave you behind at the station. Now, I'm talking about our bachelor and our master degrees and our diplomas, but bear in mind there are a lot of other ways of learning, gaining information, gaining knowledge, and it is an ongoing experience. I reckon in the next 10 to 20 years, you'll see a vast change in what qualifications are critical to your success. For example, there's things such as MOOCs, massive open online courses. I'll talk about those later, where you can get information for free. There's people like Udacity that allow you to gain what they call nano degrees, which are in IT subjects such as programming Android phones. These people, these technologies will transform what we're doing. So the classical bricks and mortar university will not be with us in 10 or 20 years' time. There will be a totally different thing. Already the university, the prestigious university up the road from me, it's been around for 150 years, students don't attend the classrooms anymore because they say it's a waste. They do it all online. So those changes are happening and they will accelerate. So online is there. So just, we obviously, that's our focus. We still do classroom sessions. That's sort of the big thing. And here's a sort of diagram. I don't know if you can all see this diagram here. Hopefully you can see it. And in this diagram, I'm trying to show you how the broad spectrum of qualifications, how they all fit together. So can you see over here, we've got the different qualifications, and I'm just going to increase my screen. You can increase the size of your screen, by the way. If you look at the top right-hand corner, you'll see a little, just top right-hand corner, you'll see a little expanded screen. So have a look at that. So what you do is, most of our students start with a trade certificate or a diploma, and then they come and do an advanced diploma, which is generally 18 months. And then they go and do a BSc engineering, which is 3 years. And then they feed in, if they want to, into a master degree, which is a 2-year master degree. Now, we say it's part-time, but it's actually part-time intensive. It's actually a 2-year full-time degree, but we do it in 2 years part-time because we make you work for 48 weeks in a year. But again, you can take 2.5 or 3 years. That's up to you. But the sessions are very highly defined. The other pathway you can come through is just forget about doing advanced diploma and go straight into a BSc engineering part-time, which takes 3 years full-time, if you do it full-time, or part-time, it'll take about 5 years to do the program, and then you can feed into the Master of Engineering. Can you see over here, when you leave the advanced diploma, you're basically a technician. When you finish the BSc, it's a 3-year full-time BSc. You will end up as a technologist, and then when you finish the master degree, if you want to go that far, you may decide at this point here, you've had enough, you're going to take a break, and you exit as a technologist. Or you may say, I'm going to continue while I'm working and continue to do a master degree, and because I want to practice as a professional engineer for whatever reason. You may find it's a good selling point in your career to be a professional engineer. Bear in mind that most engineers, whether they like it or not, are often working as technologists. And there's a third approach, which is through high school graduates, and you go straight to the BSc engineering, full-time, 3 years full-time, and then you come up and do your master degree. Yeah. And these guys coming out of school, we generally will insist or recommend they do it in a classroom, one of our classroom sessions. So that's just the overall vision of where we act, the overall vision of where we structure our programs. So that's just what I'm trying to say. So, and Shane has just given you the detailed diagram there, but you can enlarge it on the screen, as I say. So these are some of the things, the background to EIT, 120 countries, and of course we run everything from 3-month certificates of competency, 3-month courses, to advanced diplomas, which take 18 to 24 months. Again, highly practical courses. We have, oddly enough, on our advanced diploma, we have a lot of bachelor professional engineers doing them because they said, I wish I had this practical knowledge when I was at university. I'm getting it from your advanced diploma. So, for example, we have an advanced diploma in industrial automation, electrical engineering, mechanical engineering, oil and gas, etc., etc. Then we've got the BSc, which is in 4 disciplines. So you can do mechanical, electrical, industrial automation, civil engineering. Full-time, 3 years. Part-time, about 4.5 years, 5 years, if you've got an advanced diploma to bolt onto it. And then we've also got the Master of Engineering, which is a 2-year program. It sounds like a lot, 2 years, but if you exit after a year, you'll get a graduate diploma of engineering. And again, they will be in a different area, different disciplines, such as we have a Master of Engineering, Electrical Engineering, a Master of Engineering in Industrial Automation, Master of Engineering in Civil Engineering, etc., etc. So we've got about 12 master degrees in various states of accreditation, and those will be rolled out over the next 2 years. But at the moment, we've got 3 master degrees approved, and there's another 4 or 5 which hopefully will be approved before the end of the year. But like everything, you can't advertise anything until you've actually got it accredited. It's illegal in Australia and outside Australia for us to promote anything. So we're just going to talk about the stuff that we're actually running at the moment. The partnerships, we have partnerships with a whole heap of different entities around the world. Again, trying to build credibility into our programs of forming partnerships with credible organizations and avoiding the good old fly-by-night operators. So the benefit for you in doing these programs, why should you bother about an EIT program? Is it a complete waste of time? The answer is we focus on industry-orientated units. So you're actually doing stuff which you use in industry. We're looking for a high standard, but in saying that, we do have our course coordinators which work with you as a student and ensure that you get through. They don't give you the answers, they don't do your work for you, but they actually help you. They're there, personalized, to try and make sure you get through the course. Instructors are all caring, but they're all professionals working in industry. They're not just, hey, I've just designed a fast Fourier transform or something exotic. They are guys that are actually working in industry, so they know what skills and knowledge you need to work in industry. And they often are outstanding individuals. One of our guys that introduces our industrial automation course, for example, Dick Morley, is the guy who invented the programmable logic controller. You can't get anything better than that. Accreditation is really important with our qualifications. So again, the Australian government, but we're also going through some of our advanced diplomas have Engineers Australia accreditation, which automatically gives them recognition in about 10 other countries around the world, US, Canada, UK, South Africa, with a thing called the Dublin Accord. I'll talk about that in a tick. Global recognition, very important. And as I said, we have a continuous pathway from trade, diploma, bachelor to master degree. So one bolts into the other. The technical term they use, which no one really understands, is articulation. One thing articulates into another. Like a railway truck connects up to another truck. They all connect together, articulate together. And obviously the other thing is reputation is really important. If you go and do a search online for EIT, you'll see lots of hopefully good comments. Shane did some searching a few weeks ago, and there were some really good comments about the materials helping the students get promotions in their jobs and pay rises. Obviously, we can't guarantee you that, but obviously the hope is with high quality materials which are focused on the job that you will find you get some return on your investment, because it is hard yakka doing these courses. They're not easy. Supporting library, everything is 100% online, so the libraries are available online. You can get all the books, take them out. They're all online, and they are not books from 1962, but books from 2016, 2014, stuff which is up to date. Flexible, and the other thing is also our secret weapon is our learning coordinators who are very caring. And low attrition rates. We don't write your exams and we don't write your tests for you. Most of the assignments that you get, we focus on assignments rather than boring exams, where we actually can make sure that you deliver the necessary assessments. We help you get through by actually giving you all the information and all the guidance you need. Obviously, you write the assignments yourself, but the result is that you actually have a very supportive environment, despite it being online, and that helps you persist to get finished with the course. So we have a low attrition rate, which is really important because we get measured on that. So just to briefly talk about the diplomas, bachelor and master degrees, let's say we've got different areas. As I say, different disciplines. It's quite a vast range of courses. So we have certificates, which are 3-month, advanced diplomas, which are 18-month part-time, Bachelor of Engineering and master degrees. We worked out with our experiences over the last decade that you really can only work about 15 hours a week maximum on study. 15 hours of attending sessions with lectures, doing the assignments, doing the readings. 15 hours is the absolute maximum. In other words, if you had to do 25 hours a week, you wouldn't last long. The average person wouldn't. So we have structured our courses so part-time, that's sort of the maximum time. Now, if you're a whiz kid, you can probably do it in 4 or 5 hours because you know the topic backwards. If you are struggling with the material, you've got no experience, 15 hours will probably be the extreme, 15 to 20 hours. But 15 hours is our target value for the time that you take. And we selected that and we've structured the courses so that's the maximum. So you can actually get through the course by not overloading yourself. We force you to attend the lectures, although we do give you recordings if you're flying out to an oil rig or you're busy or you've got some family emergency. But the reason why we try and keep you going is because we know by keeping you up to date with the material, you're more likely to pass and keep trucking on, because it is running a marathon, not a 100-meter sprint. Now, here's a list of courses, and I'm just going to, you can see the rich range of courses there. Those are the sort of dates they start. You've got bachelor degrees near the bottom. And there's a range of different courses here. Advanced diplomas. And the idea is with the range of courses, you can actually select which one you want, and then there's a starting time. But of course, just bear in mind, we're running these courses frequently. So if you do happen to drop out of one because you can't keep up because you've got some other thing happening, you've got to do emergency work, or you lose a few weeks, you can join the next cohort, the next group of students coming up behind you on their course, because every 6 months we're generally starting one of these new courses. But before I go any further, I'm just going to ask Shanae and Carol to chip in, if I may use that term, chip in and just say hi, and also if they can add a few words in here, rather than listening to my boring voice, which could drive you to drink. Over to you, Shanae.
Hi everybody, hopefully you can hear me okay. You'll see in the text box there I've just popped in a few links for you. You can go to our website and see the detailed schedule there, and you can just click on the courses to get an expanded course program. But yeah, if you've got any questions at the end of this or even throughout, please feel free to pop me an email and I'll get one of our course advisors to get in touch with you and to answer your questions.
And hello, I'm Carol Moverley. I'm in the IDC and EIT UK office. If after the session you think of you want more information about any of the different courses that we offer, you can go to the contact us section on our website, and you can send in a request for information, and one of our course advisors will come back to you. They'll send you all the information. If you have any additional questions after that, then we'll do our best to answer them for you.
Thanks, Carol and Shanae. Yeah, so just to quickly give you a quick rundown on how the course is structured, so you just sort of get a feeling for how the course is structured. Talking about the world of connectivity, my daughter's currently going through Serbia on her way to Croatia. This is a big earthquake in Italy. There you go. Yeah? So we're all connected together worldwide, you know, it's amazing how the internet has drawn us all closer together. So whether you're in a classroom or whether you're connected on your phone or on the internet in some way such as this, you are connected and you do have the ability to actually do amazing education and courses. So just briefly to talk about the courses, the structure. Basically, as I said, the typical time commitment that we would like to see you is about maximum 15 hours ideally. If you're a whiz kid, as I said, you can probably survive on 5 hours, but bear in mind, we want you to benefit to the maximum of the courses. So you can always just skim through the course and get 51%, or you can get 80 or 90% by putting in a solid 15 hours interaction. So we have a thing called the Moodle, which is the learning management system. You get readings and assignments. You get live interactive webcasts. So the actual instructor basically does a tutorial with you at least once a week. And we have different time zones. So you may be in the States, or you may be in New Zealand, or you may be in London. So you obviously have different time slots you can log in. And we give you all those times. We negotiate with you before the course starts. There'll be about 10 to 40 students in your group. You won't have 40 guys in your class because it's impossible to coordinate that, but probably 10 to 15 students, maybe down to 5, maybe up to 15. And then your sessions are, we give you videos as you would expect, and then we have the tutorial, live tutorials where you actually interact with other students and the instructor, and you are expected to have gone through the videos, and then we give you assignments. And then we also give you remote labs, and I'll come back to the remote labs in a minute, where you actually log into a lab, do some exercises online. Now, you may have your doubts about whether this works, but the reason is simply every bit of hardware or engineering technology today has some internet interface. You've probably heard of the IoT, Internet of Things. This is exactly what's going on today. That enables us to run these labs quite effectively. I'll come back to the labs in a tick. And obviously we give you recordings and we give you feedback. And probably the secret, let me just say, the secret weapon that we have is really our learning coordinators. These guys are over and above the instructors. They actually live with you in a virtual sense, as it were, and they actually work with you throughout the program to make sure you get through. We get a tick on the box if we can get our students through. If we have students failing or dropping out, we get a very bad reputation. So we really work hard on trying at all costs to get our students through. Obviously, the reasons why you can't continue with the course, such as family problems, illnesses, money, you know, those are things. But we will try and work with you to try and assist you as far as humanly possible to get you through these courses, because you've put the investment in. And as I say, the other thing we have is inflexible e-learning, which means that we have tutorials which we expect you to attend, because that means you absorb the material, you're more likely to pass and succeed in the course. A few other issues here with the materials. It's a virtual classroom, which you'll see it's like we're dealing now. There's a whole lot of procedures and systems. We have assignments for each module, each unit. pass marks, etc. We try and avoid the classical examination, write exam and you fail, and that's the end of it. Or we have what we call assignments through the whole course. So it's a what we call formative assessment rather than summative, rather than at the end. As you're doing the course, you're doing assignments and those add up to your marks. Obviously, we check for plagiarism and copying, but if it's your work, you can be assured you've got a good probability of getting through the course with the materials we provide. So the diploma, for example, is 72 topics over 18 months. We can give you the structures of the bachelor degrees. The bachelor degrees are individual units, but each unit, as I say, in a week, you won't be doing more than 15 hours work overall. That's work attending the live sessions, the tutorials, doing the videos, attending the videos, doing the assignments and doing self-study, maximum 15 hours a week, but it's for 48 weeks a year. So it's intensive, but it's slow, continuous work. So just obviously these new learning technologies have allowed us to offer these courses, don't compromise with the quality of education, demand the best. Many institutions don't know how to offer online. We believe we're getting very close to a good model. Obviously, they can always be improved. And as I said early on, you'll find most online education is creeping in, even into residential universities and colleges. They're all even doing that. Now, there's a question here about the 3-year versus 4-year program. The BScs, the Bachelor of Engineering that you do, are 3-year full-time. So you may find that in Australia, the States, Canada, you'll see a 4-year program. What we've done is we have a 3-year bachelor degree, and then we bolt on a 2-year master degree, and that enables you to leave the program, if you continue with the masters, with a very solid program, well beyond that of a 4-year engineering degree. It also enables you to stagger the time so you can actually get qualifications. You're not suddenly waiting 8 years to do a 4-year program part-time. Within 3 or 4 years, you can get the BSc because you've already done maybe the advanced diploma, or if you've entered the BSc directly, within 4 to 5 years, you finish the BSc, you've got something to show, and then you can continue with the 2-year master degree. And basically, we want you to be out there working as quickly as possible with your qualification. So that's why the 3+2 model works very well. And this diagram, which Shana has already given you the link to, it shows you how you go from an advanced diploma to a 3-year BSc or 4-year, depending on whether you've articulated. So you actually cut your time down of your BSc by doing an advanced diploma, and then your 2-year master degree at the end enables you to exit with a very high quality qualification, something very powerful and very job focused. And as I said, recognized not just by one university, but recognized by the Australian government. So it's a global recognition. If, on the other hand, you decide that you're going straight from your trade or your other course, you can do a BSc, normally a 3-year BSc, you can go straight into that, and you'll take about 5 years to do that program part-time. Or alternatively, as I said, you can go straight into the BSc straight from school. These remote labs are what makes a big difference to the course we offer. And we put a lot of effort into these remote labs, and believe me, Shana can tell you, they've gone from very Mickey Mouse 7, 8 years ago to something very substantial. And because of the Internet of Things, I don't know if anyone's heard of the Internet of Things. I'll just write it down there. IoT, sometimes referred to as IIoT, Industrial Internet of Things. Basically, everything today, every instrument is connected to the internet or has some interface to a computer. As soon as that happens, it means that you can access that equipment worldwide. So we have 2 sets of labs. One are simulations, which are called virtual labs, and we have very realistic simulations. And then the second one is real equipment. Yeah, thanks, Greg. Yeah, Uber is a very good example. Internet of Things. The remote labs are where you hook up to real equipment. So, for example, if you're programming a PLC, you hook up into the PLC, you do all the stuff as if you were connected to the PLC on your desk. We work really hard on this because that is really important, because that enables you to show the employer you've got real hands-on experience, not Mickey Mouse. I did it online and watched a video for 4 years. No, I actually got real equipment experience because I worked with real stuff which had uncertainty. There were experimental problems, errors, and things like that. So the labs we put a lot of effort into. And you'll find everything today is interfaced with a computer or the internet, and that makes this possible. So, for example, here's a 4-pole squirrel cage induction motor. This is a very good simulation built around a real piece of equipment. Again, trying to focus on giving you some uncertainty in the lab and hopefully a good learning experience at the same time. Other ones are flow meters. You may recognize as flow meter, and hooking up to oscilloscopes and stuff like that. So the idea is we're trying to make it as realistic as possible in your experience. Getting to the end of this little presentation, so I won't take on too much, but I just want to spend the last topic, which is very important before we open for discussion. Accreditation is really important. And you may say, well, I live in Trinidad or I live in Barbados. Where's the accreditation for local Barbados government? Well, the answer is quite simple. We don't have accreditation with tiny countries, but we generally are focused around getting accreditation with probably about 5 to 10 countries or recognition from those countries for our engineering degrees. So, for example, we've got 2 engineering advanced diplomas which are recognized under what they call the Dublin Accord. The diplomas are recognized under the Dublin Accord, and it's a group of countries, I think it's about 15 that have signed it. They recognize each other's qualifications, so you can practice as a technician. There's a Sydney Accord, which recognizes 3-year programs. So, for example, the States, Canada, UK, Ireland, Singapore, Korea, Australia, South Africa all recognize each other's qualifications. And then finally, there's a Washington Accord, which recognizes 4-year engineering degrees and the master degrees as appropriate for practice towards a professional engineer. Bear in mind that even though these countries recognize these qualifications, you still have to demonstrate practical professional experience after you've gained the qualification before you become a professional engineer or a technologist. The professional engineer is probably the more demanding of the lot. Sydney Accord, to become a technologist, a 3-year BSc is not as demanding. And obviously the other thing is industry experience. So there's a whole lot of different people that we're working with. As the qualifications are developed, we go through the accreditation process, and it's a long, drawn-out process. And you're only as good as your last accreditation meeting. You have universities, colleges that lose their accreditation for various reasons. So it's really important to keep the quality of the course up and ensure that you are delivering. Otherwise, you are history. And of course, international recognition is really important for engineering today because of the fact that engineers, technologists, technicians travel worldwide. They're not just working in Australia anymore. They're working in Papua New Guinea, London, New York, and they do want some international recognition. So that's really important to gain. So as I wind down to the end here, thank you very much. Sorry, I overshot a bit on the time here. But any questions and answers from all of you? Let me just open the floor to Shane to take over the baton for a second, and then maybe Carol can add to that. Over to you, Shane. Hopefully I haven't disappeared into the
Hi, Steve.
vortex.
Thank you very much. Yes, everyone, please, if you've got any questions, please feel free to type it in the text box, or just let us know. We can hand over the microphone. Or if you do think of something a little bit later, as I mentioned, please feel free to email me. I'll put my email address in the chat box again. Some of the questions will no doubt require some detailed answers. We have a lot of questions regarding credit, recognised prior learning, entrance requirements, costs and scheduling. So please pop me through an email and I'll ask one of our course advisors to contact you directly to help you with your queries.
Okay, good question there. Let me just answer those questions. Sorry, Jay Smith. Okay, do I need to do the Bachelor first before the Masters, or can I skip the batch? Okay, it's a very good question. Look, the problem ultimately with accreditation authorities and employers, I might add, throughout the world is that they really ultimately prefer you to have a bachelor degree. That's ultimately your signal of success. If you've got the bachelor degree and then you do the master's, you've got a pretty good combination. If you only do a master degree, no matter which university it is, it's unlikely. There are a few exceptions, but it's unlikely they'll let you register as a professional engineer, so you don't get the full status. So it's a hard one, that one. It's better to do the bachelor. A bachelor actually has a higher, should we say, I suppose, rating than a master degree, to be honest with you. But a bachelor and a master degree is definitely better than just a bachelor degree on its own. So that's an interesting challenge. So let me just go. So question answer is, if you do a master degree, you're probably going to be, you may not be able to get into, with our master degrees, you really do need a bachelor degree to enter, or something very similar. Then you can get professional recognition, because we want our guys to get professional recognition, and we want our qualifications to be recognized worldwide, and that's why we have that restriction. But you can get some universities that allow you to enter a master degree with nothing, with a trade certificate. But we're not, unfortunately or fortunately, in that area. So to answer that question, you do need to do the bachelor first, but you could get some credit for your bachelor degree if you've done other courses, or you've done equivalent courses, or you can get recognized prior learning. Phil Carter says, a good question. I already have a trade in electrical instrumentation. Am I able to complete a BSc of electrical engineering in 3 years without doing an advanced diploma? Yes. You can go straight in. Yep, absolutely right. You can do we've got a direct entry where you go straight from the trade into the BSc. You don't need to do the advanced diploma. The reason why we like people doing the advanced diploma is that it gives you some credit for your study as you're doing the bachelor degree. So you actually have a hop-off point, and you've got something to show for your labors. It's very hard doing a program which can last 4 to 5 years and not have anything to show for it over that period of time. That's why we love the guys doing the advanced diploma first, and then they get the credit towards the BSc, so it's not time wasted. But you certainly can go straight in and start from scratch in January. But it's nice to be able to do the advanced diploma for that simple reason that you can get something to show for your labors rather than just waiting for this big blank spot. And that's why I think the 4-year BSc engineering degrees that are offered by universities, they expect you to spend effectively 8 or more years studying. Who in his right mind can spend 8 years without showing anything over that period of time? That's why we're unable to run a program with that big blank spot of 8 years. It's just too long. So certainly, Phil, you can. The answer is yes, but it means you've got nothing to show during your study as you go through, but you certainly can. Next question here, Mo B. I have a South African BTEC and EIT's GRE. Do I qualify for Eng program? Yes, you would do. Yep. So what you should do is send us your transcript, show us what you've got. That enables you. BTEC is very similar to the BSc. We just need to assess it. And it's a 3-year program, and that will allow you to enter the Eng. We just need to assess it, that's all. So you can send us the details, no problem at all. Or you could get a lot of credit for a BSc if you did it, but I'd say you're probably wasting your time. You've already done a 3-year program. Okay. Okay, yeah. So next question is, thanks, it's clear. Thanks, Mr. Smith. Yeah, sorry, I can't be more. There's an Australian university, actually, University of USQ, Central Queensland University. They actually allow you to do, they let trade guys go and do a master degree in reliability. Most of the guys don't finish the master degree. They end up with a graduate certificate because they can't finish it. They leave with a graduate certificate and in maintenance engineering, and that's fine. But even if they finish the master degree, they can't get professional recognition, which is a bit of a restriction. And that's why we tend to prefer the bachelor. What's the difference between a technologist and an engineer? Very good question there, Morimo. Effectively, if you do a 1 to 2 year diploma and you exit under the Dublin Accord, it's an agreement worldwide between engineering societies. You can Google it. You become a technician. If you do a 3-year BSc program or BTech, you exit with you become a technologist. You call it technologist. Now, the word technologist isn't used much, but that's what we are using today more frequently, technologist, which basically is what the Brits English call, they have a 3-year program. They call their guys incorporated engineers, but they're effectively technologists. If you do a 4-year program or a 3-year BSc plus a 2-year master degree like we offer, you leave, you can then work towards becoming a professional engineer, and that's under the Washington Accord, again, an agreement with societies around the engineering societies around the world. The question that you say there, what's the difference between a technologist and an engineer? To be honest with you, if you look at an engineer working on a mine or in a fairly robust environment, if I can call it, you'll find most of them are actually working as technologists anyway. They're not working as professional design engineers. So a professional engineer is someone who's doing advanced design, maybe doing extensive R&D, which a technologist wouldn't do. A technologist effectively takes a design and implements it, or runs a plant and does some limited design. So that's the idea. But it's a gray area, and we could debate the names till you're blue in the face. The Canadians have probably the best approach to technologists. They have technology societies, and they actively promote technologists. But the point we're making is that with 3 years, you can get a BSc, you can start getting a job as a technologist, and you may not be paid as much as an engineer, but you can start working, getting upgraded, and start working towards becoming a professional engineer while you're working on the job, doing our master degree. Okay, any other questions? Steve, I've done the advanced diploma, but having issues finishing practically due to current economic, having trouble entering the master bachelor program. Greg Madill, yep, I understand that. Look, we do understand people have financial issues, and it's tough. The best thing I can suggest you do is just slowly finish the course off as you economically can do the course. Don't force yourself. The most important thing is to conserve your cash. Don't pour it down a course drain, whether it's to EIT or anyone else. Conserve your cash and just slowly go through the course over a longer period of time, just cash permitting. But certainly, if you have an advanced diploma, you should have more salability of your skills. We've had a lot of guys with advanced diplomas sell themselves to get jobs. They can get better jobs than they're currently doing. So you should be able to sell yourself. But obviously, I don't know what your particular economic circumstances are, but getting an advanced diploma would enable you to have more economic salability in your career. Okay, next question here. Andrew Viney. But Greg, just send us a note on your background and what you're doing to Shana, and I'll see if I can give you further advice. If you can give us more details. I think some of it's personal stuff, so I don't want you to do it on a forum I think it's private. I have an electrical trade certificate, an industrial electronics certificate, advanced diploma in electrical engineering, and in electronics engineering with a TAFE institution. Do you think I would get RPL? Yes, absolutely, absolutely right. No, we make that quite clear. Andrew, if you don't get any recognition with us, don't apply for our BSc. You will certainly get recognition, absolutely. And with that, you should get at least a one year or maybe more. So send us your application with all your details and we'll get back to you. Certainly we'll get RPL for January intake. You'll find any good university will give you recognition, definitely. Okay, and Shane Pretorius will give you more details there. Marimo B, with grade certificate of renewable energy, you wrote the exam. Is this the same with the exams at the end of the semester, or is it just an assignment? We have a mixture of both. We have a mixture of assignments and exams, but our focus is on assignments. But we do have some exams, but they are limited. The reason why we have exams is because we have to show the accrediting authorities and we have to show the world that we're rigorous about our assessments, that the fact that you're sitting somewhere in the world, we can assess you with the same quality as someone in a classroom. So we do have a few exams, but they're not major. Most of our stuff is what you call sort of formative assessment, which means you assess the person as he or she goes through the course. You don't have a suddenly one bang assessment at the end with an exam. That's unfair. And you'll find most universities recognize that today, and they're less prescriptive about exams. Okay. Yeah. Oops, sorry, what's going on? I've just lost everyone for a moment. Hang on. I've got something jumped onto my computer. Sorry, I just disappeared. There's something jumped onto my computer there. Got lots of people calling me, so sorry about that. Hopefully I'm still with you. You can still hear me. Oh, sorry, Carol, I just had a little thing jump on. Okay, let me just pass you back to Carol. Do you have anything to add?